Okay, everybody, welcome back to part 2. We'll be working on question 3. I'm going to go ahead and write it out. Dot plus 5x dot plus 4x is equal to 2 unit step function of t. Okay, initial conditions being x naught equals 2, x dot of 0 equals negative 3. Okay, let's go ahead and get started. X double dot turns into s squared x of s plus, so I need to remind myself, right? Negative s x naught negative x dot. So okay. X dot is equal to s x of s minus x naught. So plus 14 plus 5, sorry, plus 5 x of s minus x naught. Okay. And then plus 4 x of s. That's all equal to 2 over s. Right, and we discussed that this right-hand side is going to be the forced because it deals with the input unit step function, and the left side is going to be the free response because it deals with our initial conditions. Right, we talked about force dealing with the input, free dealing with the initial conditions. Okay. Now, next step, if you remember from part 1, we're going to isolate x of s. Okay. So I'll go ahead and highlight this to make it easier. These are all the terms that have x of s. These are all the terms that are our initial conditions. So we're going to isolate x of s. Okay. First, we're going to distribute out of the s squared term. So s squared plus 5. Oops. I think there should be an s here. Yep. Forgot to write an s there. 5s plus 4. Okay. And then I'll go ahead and fill in all of my initial conditions. So x naught is equal to 2, so we have minus 2s. X dot naught is equal to negative 3, so we have plus 3, negative 3, right? And then minus x naught is minus 2. Okay, so it's all equal to that. So 3 minus 2 is 1, minus 2s plus 1. Okay. And then we'll go ahead and just, I think by now, right, we can understand that we're going to just subtract this guy from both sides of the equation. Right, so we're going to get something that looks like 2s minus negative 2s plus 1. Okay. That's equal to x of s times basically this, right? And I think from there we realize we can divide both sides by our quadratic equation. So we're going to get x of s is equal to 2 over s minus, sorry, 2 over s. I'll go ahead and factor this real quick. Looks like it's going to be s plus 4 and s plus 1. And then minus negative 2s plus 1, s plus 4, and s plus 1. Okay. Now, let's go ahead and do partial fraction decomposition. We're going to do a over s plus b over s plus 1 plus, sorry, doing this all wrong, b over s plus 4 plus c over s plus 1. And we're going to do a times basically our quadratic formula, so s squared, sorry, quadratic equation, not quadratic formula. Sorry, I didn't mean to bring some trauma back. Okay, just like that. In other words, it's going to be as squared plus 5as plus 4a. Right. Now for b, it's going to be b times s and s plus 1. Okay. So it's going to be bs squared plus bs plus 0 for the constant term. And then we're going to have c times s squared plus 4s, right? Same thing like this. Instead of the s plus 1, it'll just be s plus 4. I just went ahead and distributed everything already. So it'll be cs squared plus 4s, right, plus 0. Yeah. So this is our matrices, so to speak. And so we know that we don't have any s squared term. There's no s squared term and there's no s term, but we do have a constant term. So we know that a plus b plus c for the s squared term, right, has to equal to 0. We know that 5a plus b plus, this is 4cs, right, plus 4c has to also equal 0. And we know that 4a has to equal 2. So in this case, a is equal to 2. And let me just check real quick just to make sure that so far everything looks good. Sorry, a is equal to 1/2. My bad. Okay. I don't know, I had a spidey sense that something was off there. So continue on. We have a equals 1/2. Okay, next equation we're going to use did I do this correctly? Oh, I see. We're going to have to... Okay. So it's going to be... use these two equations, 1/2 plus b plus c, 5/2 plus b plus 4c, both equal to 0. Go ahead and subtract them from one another. I'll probably go ahead and put this one on top so that we get positive numbers when we subtract. So 5/2 minus 1/2 is 4/2 plus b, b cancels out. So I'm subtracting this equation from the top equation, right? So b just cancels out. This would be negative b. Okay, and then c, 4c minus c would be 3c. Okay, so 3c is equal to negative 4/2, which would be negative 2. Okay, so c is equal to negative 2/3. That is correct. Okay, and then b is equal to, if we look at this equation, let's choose this guy to plug in. We have 1/2 plus b minus 2/3. It's equal to 0. Okay, b is equal to 2/3 minus 1/2. Put this into the same denominators. We get b is equal to 1/6. Okay. Sorry about the notification. I really do have to silence when I start recording. Okay. And I just want to erase all of this noise real quick so we can start from a fresh plate. Okay. We'll move these all up. And let's go ahead and do our Laplace inverse. Okay. So we're going to do 1/2 times 1/s plus 1/6 1/s plus 4. Okay, plus c is going to be, negative 2/3 1/s plus 1. Okay. So this 1/2 1/s just becomes a constant when we apply the inverse Laplace. Okay. This becomes plus constant term first, 1/6 e to the negative 4t, and then this becomes minus 2/3 e to the negative t. Okay, this is all using our inverse Laplace. Right, and this came from the 2, right? And the 2 was originally with our unit step function. So this is actually categorized as the forced response, right? This is going to be our forced part of a response, meaning that it is the input into our system of differential equations. Next, let's go ahead and work on the right side. So we're going to go ahead and do this side, partial fraction decomposition. Okay, so we have negative 2s plus 1. You know what? I'll go ahead and distribute that negative in there. So we'll say that it's positive 2s, right, minus 1. Okay. And then we're going to go do the same thing with the bottom. And this will be equal to a plus s plus 4, a over s plus 4, plus b over s plus 1. Okay. Let's see. So it'll be a s plus 1, so as plus a, and it'll be bs plus 4b. Okay, so we can see that a plus b has to equal 2, and that a plus 4b has to equal negative 1. Again, I'll just do elimination, so I'll go ahead and put this one on top, this one on bottom. Okay, so this is subtracting this equation from the top one. We're going to get 0 for a, and we're going to get 3b is equal to negative 1 minus 2, which is negative 3. So b is equal to negative 1. Again, I'm going to go ahead and check myself, make sure my math is incorrect, in which case it might be a little bit. I should have a 2s plus 7. Okay, let's go back and check. Did I mess up doing any of these calculations? Oh, I see where I think I went wrong. Yes, we forgot to distribute. We forgot to distribute the 5 into this x naught. And that x naught would have been this 2. So that would be a minus 2. So instead it would have been a minus 10. Nice. And 3 minus 10, that would get us a minus 7. Right. Subtracting that from both sides, this would have been negative 7. Little tiny errors here and there. Okay. And then now when I'm doing this part, when I distribute that negative, this will be a positive, so 2s plus 7. Okay. So that means that this would be a 7. Okay. Now that means this would be 7 minus 2 would be 5. So b is equal to 5 divided by 3. Okay. And this, if I go ahead and check this on the other side, is also correct. Okay. Next, we'll solve for a. We'll use this equation since it's easier. A plus 5/3 equals 2. So 2 minus 5/3, if we put this over 3, that'll be 6. So a is equal to 1/3. Okay. Yeah, now I'm going to go ahead and erase all this noise now that we found our a and b constants. And we'll go ahead and put this into its forced response form. Sorry. Okay, that's right. I just want to erase this part. Keep this up. So it'll be 1/3, 1 over s plus 4, and 5/3, 1 over s plus 1. Okay, now I can erase these. This will be, because I distributed my negative already when I did all this, this will just be a plus, right? And this will be the free response. Again, the free response deals with the initial conditions, right? All of these terms have to deal with the initial conditions in our original equation. So next, we're going to go ahead and do the complete response. So complete. Okay, we're going to combine all the like terms. Oh, sorry. Forgot to do inverse Laplace, my bad. So this would be 1/3 e to the negative 4t plus 5/3 e to the negative t. Okay. Silly me, almost forgot to do one of the most important steps. Okay, and now we can combine like terms. So we have e negative t here, e negative t here. Right, we can't combine negative t and negative 4t. So these guys are going to combine with each other, and our constant term is the 1/2. So we're going to do negative 2/3 plus 5/3, right? That's going to get us 3/3. So that's actually just e to the negative t is our first term. 1/6 plus 1/3. 1/6 plus 1/3. So that would be 2/6 plus 1/6. So that's going to get us 1/2, right? 3/6, just 1/2. So plus 1/2 e to the negative 4t, okay, plus 1/2. And that is our complete. Now, as promised in this video, I'll show you how to check your answer using MATLAB. Okay, so we're going to have to go back to our original equation. Let's see. I'm going to go ahead and take this. I'm going to make it a little bit easier for myself to type into MATLAB. Okay. Let's go ahead and copy this, bring it down. Okay. I'm just going to combine both these into one fraction. So again, that'll be 2s plus 7s squared 7s, right? Plus 2 on the top. And then on the bottom, we'll have s, and this will be s squared plus 5s plus 4. Okay. In fact, I'll go ahead and just distribute in. So I'll just make this s cubed plus 5s squared plus 4s. Okay. Now, we're going to go ahead and take this, what we wrote right over here, and we're going to do the inverse Laplace. So I'm going to switch to my display of my screen. All right, guys, we're back in MATLAB now. Now, the function that you're going to use in MATLAB is called ilaplace. We're going to use semicolon, and then we're going to do pretty ans. Now, kind of a cute function descriptor, right? Pretty ans. That's going to make sure that our final answer is readable. Super important to put this system s, otherwise it will not recognize our s variable as the Laplace domain. Also, another thing to note is this MATLAB Laplace function actually requires an add-on that you must download. I believe that if you go ahead and try to use this ilaplace without it, it'll tell you exactly which one you need to download. Okay. So I'm going to go ahead and type in our earlier expression. 2s squared plus 7 times s plus 2. Okay. And then I'm going to use parentheses to close that off. Make sure our PEMDAS works good. Another parentheses, s raised to the third power plus 5 s squared, and then plus 4s. Sorry, multiplication. S cubed plus 5s squared plus 4s. Okay, I think everything looks good. Hit enter. Invalid when calling it otherwise. Check for mismatch cylinders. I keep forgetting to do that. Yep, so that's exactly what I meant to do. Right here. Perfect. Lovely. So that is our expression. And if we match that up with our expression that we solved previously, it would be correct. E to the negative t, 1/2 e to the negative 4t, and 1/2. So this is a way you can use MATLAB to check your work for Laplace transforms.